I'm going to show you the Dorsey 16-inch optical comparator. This machine has a 6 by 10 inch travel and a 3-inch focal plane. It also, the 16-inch means the screen is 16 inches in diameter. What does that mean? That means at 10x, you can see 1.6 inches apart on the screen fully. It's nice for overlay work, but it's also nice just to see the whole part in the full screen to see where you are when you're measuring. This machine is the only machine on the market with a cast granite base. It weighs about 460 pounds, and the X and Y axes are bolted to that granite base, as well as the focal holder for the lens itself, which lends itself to be a very accurate and stable machine. One thing I like about this machine the best is the surface illumination qualities. If I pull out my surface illumination and I turn the light on, you can actually see the surface of that quarter. Now this machine is erect and incorrect, meaning top and bottom are right, but right and left are reversed. As I come in from the right side, you'll see I'm coming in at the left on the screen. Now, because of the surface illumination, it gives me the ability to measure inside the part, where before, without it, I couldn't see the feature. Another nice feature of this machine is its tremendous positioning accuracy. If I come up to my edge over here, I focus in on edge, let's say I zero out my readout in the X, and as I move up, you can actually watch the display move a tenth at a time. 3, 4, 5, it's a half a thou. Here's a thousandths away from my line, and if I want to move 10 thou, I can actually move it 1/10 steps at a time. You'll notice as I move it, it calculates the next step. If I take my hands off, there's no creep back on the stage. I can do this with up to 150 pounds of weight with no deflection. Similarly, I can do the same thing in the X. If I zero out my X in the corner here, and I walk away from the line, I can actually move 1/10,000th at a time. So if you look at it, if we move, let's say, 5 thousandths from the line, at 10x, it's very easy to see the light between the line and the part itself. So you can easily see errors in the thousandths with this machine at 10 power. All machines also come with a bayonet style lens. It's got to be turning in place, so if I want to replace the lens in this machine, I'm going to pull it off. We'll take my 20x lens. You notice there's a little red mark. You can line up to the red mark on the machine. I'm going to put the lens in, crank it until it locks in. Come up to our position, and obviously we're seeing twice the size of the part that we had before. Now note, a higher mag lens does not make the machine twice as accurate, but it makes you a twice accurate operator because you can see the line and the edges a lot clearer at a higher magnification. The only caveat to higher mag is you sacrifice a little bit of light. At the higher mags, at 50 and 100x, we do offer a diopter which extends the light about 25% in brightness. I'm going to show you a little bit of the Quadra Chek digital readout box. We're going to come over, put my part on here. And we're going to start doing some basic measurements. The first thing you want to do is put your part up and set your focal plane to the position that you want to be in focus on. Well, the first thing I always do with a part like this, I make sure it's squared off. Your focus is right here to the right of the column, and it's about a 3-inch travel of focus. I can fit about an 8-inch part between the lens and the screen itself. So the digital readout box is made by Quadra Chek Heidenheim. It is made in Jamestown, New York, as well as this machine is also, the carcass and everything except for the lenses are made in Poughkeepsie, New York. So it is a US made product. And the Quadra Chek box is been around for a long time. It is a full geometric 2D box, so anything you can see in 2D you can measure. And it gives you the ability to measure a point, a line, a circle or a radius, a distance between any two entrant points or any two features, an angle, and skew your part. So I'm going to just touch on a few features of the Quadra Chek box. This box can be hooked up to a Hewlett-Packard printer and directly print out without a PC, or you can dump your data down into a laptop and a PC via the serial RS-232 port. So with the Quad box, it's pretty easy to use. Your current position tells you where you are in the XY on the stage. You actually have an inch key here, and it's telling me I'm using datum number 1. And I'm going to evaluate my points with the crosshair. So, if I use these keys right here, it controls this corresponding line. So I get a millimeter and inch direct conversion. I can use datum 1 or datum 2. And I can also use Cartesian position, or it can give me polar and the angled inclination of that polar line. You also have a mini help within the box, so it will help you within the display you're in. So if you're in the DRO display, it'll give you DRO help. If you're in the circle mode, it'll give you help for the circle. When in doubt, quit out, and it gives you back to your display. So right now my display is just reading as I move my X and Y crosshair. First thing I want to do is to comp for any tilt in the part, I'm going to skew my part, so I'm going to use the skew key, and I'm going to enter 2 positions on the skew line or my reference line that's in my drawing. So the first thing I do is I come up to my edge, it's telling me to probe a skew, I enter my first point. Now I can enter as many as 99 and as few as 2. Second position, and my last one. So if I hit my third position, I tell it finish, it creates an arbitrary 0, 0. In this case, the X doesn't mean anything to me, but more importantly, the Y does. Because what happens now, the Y is set 0 to my reference line, so now my part is electronically skewed in the memory of the machine so that any points referenced to that edge will be parallel or perpendicular. You'll eliminate any cosine error you might have if you tilt the part. So, if I go down the part, the Y-axis and the X-axis are going to correspond to that 0 point. If I come over to this corner now and mark 0 on my corner, I create the 0, 0 position between the top edge and the side corner. Now that I've skewed the part, and this part should be 90 degrees to my reference edge, it should be 0 all the way down the part. We'll see how good the part is made. And we go right there. Pretty good. Half a thou, not too bad. Alright, so now that I have that zeroed here, if I want to do a quick distance, I know that 0, I can run right across to the part. Make sure I'm in focus, go to the corresponding edge, look out your display, 5250, it's measuring correct and skewed. And that's the overall distance of my part. Now it's really nice to measure your distance and 0 out, but sometimes you don't want to lose your datum. My datum number 1, I didn't want to lose that. Okay? So you have the ability to do datum 1 and datum 2. So I have datum 1, my absolute datum, I can turn datum 2 on, it's now my incremental datum. So I created an incremental datum on the edge of this part. So if I wanted to, I could 0 out, and now go and measure the distance, to say any distance. Let's say we'll go to the, let's say the top of this circle for laughs. So I measured my distance x to the top of that circle, 2.446. If I go back to my original datum, I have not lost where my position is. So now we know that's 3 inches from the original 0. You also have the ability to look at your Cartesian coordinates at any time. So you can go from Cartesian to polar, either datum 1 or datum 2. It'll tell you the straight line distance and the angle. Okay. So we have skew. The next key on our list is angle. And this will calculate an angle for you and the complementary and supplementary angles relative to the 2 lines. So let's say we come up to this corner, we're going to measure this 90-degree angle here. So I always line up my crosshairs to the first leg of my angle, generally lay out where the first point's going to be, and then I ask for the angle key. So if I go angle, It wants you to probe an angle. I'm going to enter a minimum of 2 points, a maximum of 99 on the legs. So I've done 2 points on that leg. I tell it I'm finished. And it calculates leg 1 in the memory, but I'm still in the angle measure mode. So if I come over here and do the second leg, enter 1 point, 2 points, 3 points, tell it I'm finished. It calculates my angle. And you'll see it's a perfect 90 degrees. In the position closest, the vertex point, which I had made 0 before, is now 0, 0 in my 2. And that's the distance from my original 0, my absolute datum number 1. So I have the angle key. If I rotate it, you can view it and actually see your complementary and supplementary angles drawn. So you'll start with your 90, that was the included angle we measured. Then 360 minus 270 degrees. And then the 90 on the other side. And then back to 90 again. You also can look back at the lines that you measured as well. There's my line number 3, which is my second leg. And line 2, which is my first leg, with 2 positions. They're also on the feature list, so you can use them later for different calculations, distances or intersection points. We'll go back to view, remove my readout, and it brings us back to current position. Now let's say, I wanted to make that angle 4, 0, 0, I forgot. I'm going to make it 0, 0 in my absolute datum, so I can always go back and look at the feature list by the up arrow keys here, and toggle through any feature and see what the output is. So if I go back to angle 4, it's showing me the angle I measured at the XY position. Now to make my absolute 0 or my datum 1, 0, 0, I can simply 0 the readout at that point. So now I've created a new 0 at the corner of this angle. So if I bring my readout up, it'll tell me where that theoretical intersection point is. There's my first 0 and my second 0 right there. Okay. So now I've created a new 0 relative to the vertex point of that angle I created from lines 2 and lines 3. The next key is distance key. The distance key is going to tell you the distance of any 2 entered point or any stored feature in your feature list. I like the distance key because it gives you a feature you can go back and look at instead of just using your digital readout. When you 0 it out, you lose it forever. So I'm going to ask for distance, and basically in this one it wants me to enter 2 positions. So I'll enter distance 1. We'll go to the other side. Enter distance 2, tell it you're finished. And it calculates your distance, the X, 521. Your Y, I didn't move at all, and because the part is skewed, the X and the Y should be the same anyway, 52511. If we view it, it actually shows me the distance between the 2 positions. But more importantly, it's on your memory list, so you can go back and look at it any time. There's the angle, there's the line, and there's the distance I actually calculated earlier. Now if we had a printer attached here, I could hit the print key, which is right here, and it'll dump my data to a printer. Or we could dump to a laptop or a PC.